What we're going to be working on next is solving quadratic equations by completing the square. In a quadratic equation, they will usually start out in this format: ax squared plus bx plus c equals 0. In order to be able to complete the square, what you want to do is start out by having all of your x terms on one side of the equation and then your constant term on the other. So we would need to get all variable terms on one side, and the constant term on the other. After we do that, we're going to need to check to see if a is 1. If a is equal to 1, you are fine and you're ready to start with completing the square. If not, you need to make sure you divide each term by a. Remember that a is the coefficient in front of the x squared. So in other words, x squared must have a coefficient of 1. After you have x squared with a coefficient of 1 and all your variable terms on one side and your constant term on the other, we're going to start by finding half of b. Now b is the number in front of the x term. So we need to find half of b, or b divided by 2, or b over 2. Then we're going to square that and add it to both sides. Of the equation. We're always adding that to both sides of the equation. Notice that half of b will not always be positive, but when you square it, it always will be. So that's why we're always adding it to both sides of the equation. After we've added that to both sides of the equation, we are going to factor the side with the variables. You'll see as we start working them that this will always be a perfect square. That's why this is called completing the square. So it will always be a perfect square, and it's going to factor into x plus that b over 2 number that you found squared. And at that point we have the same setup that we had when we used the square root method. So we're going to take the square root of both sides. And we always want to remember the plus or minus. Since we are introducing the square root to the problem, we have to include plus or minus. Remember the plus minus, and then solve for x. Sounds simple, right? Let's try a couple of examples. We'll start with x squared plus 10x minus 24 equals 0. The first thing we need to do is get the variable terms on one side and the constant term on the other. So we will be adding 24 to both sides. So we have x squared plus 10x. I'm going to leave a gap, and you'll see why I'm doing that in a second, equals 24. So I have a space after my 10x. Step 2 is a equal to 1. So I'm checking to see, is there a coefficient in front of the x squared? And there is not. The coefficient is 1, so I'm on to step 3, which was find half of b. Now b is this positive 10 in front of the x. So half of positive 10 divided by 2 gives me 5. And then I'm going to square that. 5 squared equals 25. Now this 25 is what I'm adding to both sides. So I will add 25 in this space, which is why I left it, and I will add 25 to this side of the equation. My next step is to factor the side of the equation that has the variables. And remember I said that it will always factor as a perfect square. So you notice that the first term is a perfect square. It is x times x. The last term is a perfect square. It is 5 times 5. And if I do 2 times f times L, I get 2 times 5 times x, which is my middle term. So it actually is a perfect square, and it factors into x plus 5 squared. Here's an important thing to notice. See this half of b number? That is what we can use to factor this very quickly. It will always be x plus b over 2. If b over 2 is negative, it will be x minus that number. We have x plus 5 squared equals, go ahead and do 24 plus 25. We get 49. And now it looks just like the problems we were doing when we were solving by the square root method. So we will take the square root of both sides. Square root of x plus 5 squared is just x plus 5. Square root of 49 is plus or minus 7. And then we've got to solve for x. So we'll subtract 5 from both sides. Remember that that negative 5 goes in front of the plus minus. So we have x equals negative 5 plus or minus 7. And we, since we have like terms, we have to go ahead and finish those two problems. So we'll have x equals negative 5 plus 7 is 2, or x equals negative 5 minus 7, which is negative 12. Let's do another one that's pretty straightforward, and then we'll move on to one that's a little bit more complicated, but not too bad today. Let's try x squared minus 2x plus 4 equals negative 6. The first step when we're solving by completing the square is to get all your variable terms on one side and your constant terms on the other. So in order to do that in this problem, I will need to subtract 4 from both sides. So I have x squared minus 2x. Remember, I'm going to leave a gap there, equals negative 10. Next thing I need to do is check to see if the leading coefficient on the x squared here is a 1, which it is. So I'm ready for my next step, which is to find half of b. b is negative 2. So when I take negative 2 divided by 2, I get negative 1. I have to square negative 1. Negative 1 squared equals 1. And this is what I'm adding to both sides. So I'm going to add 1 in this gap here. I'm going to add 1 to the other side. The next step is to factor this left side. And remember what we said on the last one is that this number here is what helps us to factor it very quickly. So x squared minus 2x plus 1 is going to factor into x minus 1 squared equals that negative 10 plus 1 is negative 9. And I'm ready to take the square root of both sides. So square root here, square root here. I get x minus 1 equals, that square root of negative 9 is going to give us an imaginary number. Square root of 9 is 3, and then the negative gives us an I, so it will be plus or minus 3i. I need to solve for x, so I will add 1 to both sides of the equation. Remember that goes in front of the plus or minus. So we'll have x equals 1 plus or minus 3i. Since those are not like terms, I can't combine them, so it doesn't matter if I split it or not. I could split it to x equals 1 plus 3i or x equals 1 minus 3i, but I don't have to. Again, notice that these are complex conjugates of each other, which will always happen when you solve a quadratic equation that has any complex root. It will always have two complex solutions. this is going to be our last example for this session. Next time we will be working with problems that have fractions. So get excited about that. Okay, first step. We want to make sure that all the variables are on one side and the constant term is on the other. They are on the same side, but notice they're not in standard form. So I do want to go ahead and rearrange that so that it is 3x squared plus 18x equals 45. Okay. On to the next step, which is to make sure that your leading coefficient is 1. It's not. I have a 3 in front of that x squared. So I need to divide each term by 3, which will give me x squared plus 6x, I'm going to leave a gap now, equals 15. We're ready to find half of b. 6 divided by 2 is positive 3. And then remember, I'm going to square that. 3 squared is 9. 9 is the number I'm adding to both sides. So I'll go plus 9 and plus 9. And then factor the left side. Remember, I'm using this positive 3 to factor quickly. So I have x plus 3 squared equals 15 and 9 is 24. And now we have that square root method. Take the square root of the left side, square root of the right side. Square root of x plus 3 squared is just x plus 3. And the square root of 24, 24 is not a perfect square, but it does break down into 2 times 12, and then 12 breaks into 2 times 6. So we have 2 times 2 times 2 times 3. So this pair of 2's comes out, turns into a 2. This 2 and this 3 both stay in, and it becomes 2 times 3, which is 6. So I will have plus or minus 2 square roots of 6. Then I need to subtract the 3 from both sides. Remember, that goes out in front of the plus or minus. So when we're finished, our solution is going to look like x equals negative 3 plus or minus 2 square roots of 6. Now again, this is kind of like the last one we had, where we don't have like terms, so we really could split it into negative 3 plus 2 square roots of 6, or x equals negative 3 minus 2 square roots of 6. But we don't have to. We can leave it in this format. Notice again that these are conjugates of each other. So we have the same conjugate situation when we have irrational solutions, just like we do when we have imaginary solutions.